Hello, in this video I'm going to present the second project for the OpenCV apps course. This project consists of finding the, the, the celebrity that looks like this image. We have two test image as example, one of a girl that looks like Selena Gomez and the other a guy that looks like Amitabh Bachchan. I don't know how to pronounce that, but we're going to try to find the celebrity that matches that matches greater this image. Okay, for this we're going to use the celebrity together datasets. We just have here a subset of that datasets, and that is saved on this location. And here is explained the format of the folders that we have in the resource of the Jupyter notebook. And we also have a self mapping which has the number of the celebrity and its name. Here we import the libraries that we're going to use. For this project, the code was very similar to the one in the face recognition using the leaf, so I used most of the code from there with just little modifications, but that took several times until I find out what was the reason that it wasn't working. But let's dive in the code. Here we load the predictor path for the face landmarks and also the face recognition model, which is based on the leaf using ResNet convolutional neural network. Here we explore the data and we say that the face dataset folder is located in this location. We explore the subfolders and append them. Then we have the name label map, dictionary, and also we have labels and also image paths. Yeah, here, image paths. On image paths, we're going to have all the paths of all the location of the images. On labels, we're going to have all the number of persons that can be possible to find in the dataset. For example, for Selena Gomez we have 5 images, so that means that we're going to have 5 times the number of Selena Gomez. And for name label map, we have the location of the images and also the identifier. Okay, for example, N00102, that's the identifier. Here we have the label, the name mapping file that is provided in the resource. Here we have we need to sort the image paths because I don't know why, but when I was when I was appending all the image paths, they came in not in order, so I need to sort them in the ascending way, so it's better organized and I could debug better the code because I was not getting good reasons of what was happening. This part of the code was provided in the notebook. It is just showing how to access the image files and also how to get the celebrity names of that image, and also is showing the path where is located that image. Okay, then we have the to-do section where I was required to develop the code. So in this part is enrollment of celebrity images. Mm, and here we are doing the same as the face recognition using dlive, but but I just with one little plus thing, and that was the thing that got much time for the to find out what was the reason that it wasn't working. So here we have all the image paths, and we're processing one image by one image. We read the image on that image path. We use the face detector, and we then loop through all the faces detected in the image. Normally, we know that we only have one face in for every image, but maybe we could have two, so we need to loop in all of the faces. But here happens that maybe the face detector didn't detect a person, so that means that this is going to be this index dict yeah, this index dictionary is going to have less items than the image path length. That was the thing I was not realizing, but finally I did. So, and that happens because maybe sometimes the face detector didn't detect a face, so it doesn't pass through this section. And we have the length of index is smaller than image paths. Okay, and here it's the same code as face recognition using dlive. We use the shape predictor, we get the landmarks, we convert the image, the test, no, every image of the datasets. We get the face descriptor of that image using the face recognizer and compute face descriptor function. Okay, then we convert face description from dlive format to list and then to numpy array. And here we'll save that numpy array on face descriptor and in the array. We stack all the descriptors, which are a vector of 128 values. Yes, and at the end we save all the descriptors and also the index. And as I mentioned, the index dictionary is going to have maybe less items as the length of image path, because on some image maybe a face was not detected. And here we also need to save only the paths. Here we save only the paths that have a face detected. We don't save the images that we couldn't detect a face. Okay, so that means that this dictionary is going to have less items than the original one. So the original one have 5,830 images, but in this one, in the image path face detected, we're going to have less, because maybe on some images a face was not detected. Here we're going to start using the test images, but before we need to load the descriptors and the index that we had previously. And here we only read one image at a time, one of the test image at a time, and we convert it to image dlive format, which is RGB. We detect the faces on every image, and also we consider that if we have several faces in the same image, we're going to loop through all the faces. Okay, here we do the shape predictor of the face. Here we get the points of the face rectangle. we compute the descriptor of the image using the face recognizer and the function compute face descriptor. Then we convert the descriptor from the leaf format to list and then to numpy array. And we store it in this variable. And then we're going to calculate the Euclidean distance between face descriptor and calculated on face, detected in current frame with all the face descriptor we calculated while enrolling faces. So we're going to use the function np len_alg norm to get the distance between all the descriptors enrolled and also the test face descriptor in the array. And we're going to care only where we find the smaller distance. That means that the test image is very similar to that cluster of images. And we're going to get the argmin. And we're going to check if the minimum distance is smaller than a threshold based on what specifies the leaf. Specifies that if it's less than 0.6, that means that is the same person. So we're going to check that, and if that occurs, we're going to say that the celebrity name is the same as it comes in label map, and we're going to look in the dictionary for this number. Where is the argmin? Where we have the smallest distance. So that means that the test image looks like a person in the datasets. And the last thing we need to do is we need to show the picture of the image that was close enough to the test image. So for example, for this test image, the picture in the dataset that was the closest was this. And for this test image, the picture in the dataset that was the closest was this Selena Gomez image. Okay, and here we use the image path face detected dictionary that we have, and we look through for the argmin path, and we read the image that is on that path, and we show the picture of the celebrity that looks alike. Good.